Hi everyone, I'm Tong Yu and I am a PhD candidate in computer science at University of Minnesota. Today, I'll present my work like a rolling stone, effects of space deformation during linear acceleration on slope perception and cybersickness, which is done under the supervision of Evan Suma Rosenberg and with the support of Isaias Adhanom. In this paper, I propose using slope simulation to restore the decoupled optic inertia relationship, or commonly known as visual vestibular conflict, during virtual acceleration. We know VR have this undesirable power of making users sick during virtual locomotion. This is because when we navigate in VR, our bodies are not physically moving. As a result, the optical flow we see is not correlated to inertial force changes. Sensory conflict theory and posture instability theory both try to explain why such discrepancies can make people sick. But in any case, we might be able to mitigate cybersickness by restoring the relationship between optical flow and inertial force. In the real world, like Figure B, the optical flow and gravity inertial force are coupled by physics. An inertial force is a force that an object receives when accelerating. Since gravity and inertial force are equivalent according to Einstein's general relativity, we describe their vector sum together as the gravito-inertial force, like the pink arrow. But like Figure A, if we navigate in VR, there won't be much inertial force. So we need a situation where the gravito-inertial force is perpendicular to the ground like this, and could still afford acceleration naturally. That's where slope comes in. A slope naturally affords acceleration. In Figure C, when accelerating freely on a smooth inclined plane with slope angle theta, the acceleration is g times sine theta. This inertial force cancels out the component of gravity along the direction of slope, and the gravity-inertial force direction is perpendicular to the plane, with magnitude g times cosine theta, which is very close to g when theta is small. That's why we chose to simulate slopes to mitigate cybersickness during virtual acceleration. Inspired by this idea, I propose the following geometry transformation to simulate the structure of a slope. The idea here is to manipulate the orientation of virtual objects to change users' perceived orientation. We deform the flat space like Figure B into something like Figure E, and Figure F is the slope we are trying to simulate. Note that if you rotate Figure F counterclockwise, it is identical to Figure E, including the direction of gravity inertial force. Here is an example of the virtual environment after the proposed deformation. For uphill slope simulation, you can see the area in the distance being occluded. And for downhill slope, the distant area is more visible. I implemented the space deformation with virtual locomotion. When the user pushes the joystick and starts to accelerate, the ground changes gradually from flat to bend, and vice versa for deceleration. However, simply tilting the distant ground creates a rotational motion that could make people uncomfortable. As a result, I also created the pinch effect where the length of the slope was changing during transition. This makes the ground bending less like tilting. We hypothesized the pinch effect would be more comfortable than tilt. We conducted a user study to evaluate the proposed space deformation technique. We had three conditions. In the pinch and tilt condition, the space deformation would take place with the corresponding transition effect. We hypothesized that space deformation could mitigate cybersickness. We also hypothesized that the space deformation would create a feeling of being on slope. We recruited 87 participants, including 41 female, and conducted a between-subject study. We measure user cybersickness level through the SSQ questionnaire and discomfort scores. We also measure users' slope perception by asking if they felt like they were on a slope. The questions were embedded among other decoys, like previous papers. During the study, participants spent about 20 minutes in the virtual environment navigating a city. They were instructed to stop and start at each stop sign. The whole session involves roughly 120 stops. During acceleration and deceleration, we simulated a 6-degree slope, which corresponds to an acceleration of 1 meter per second squared. Here are the results. Both SSQ and discomfort scores did not show any significant difference between conditions, and our predictions on cybersickness and discomfort were not confirmed. It is possible that the benefits of space deformation was canceled out by discomfort induced by the ground bending transition effect. Participants reported that the gradual ground bending makes them feel uncomfortable. Also, the overall cybersickness level is relatively low, as is shown here, suggesting a floor effect. Due to these factors, the current implementation of space deformation may have little opportunity to provide a benefit for cybersickness. The viability of this remains an open question. For slope perception, here are the box plot for the answers to all the questions. The median rating for the questions on bending and slope perception was 7 in conditions with deformation, which is the highest possible rating. And the median for all other questions were either 1 or 2. This result indicates our technique creates a realistic feeling of being on a slope, while users were actually standing still on a flat surface in the real world. One participant mentioned it felt like a ball rolling down a hill, and that's how I got the title. There are a number of limitations in this study. First, since only linear acceleration was involved in this study, the overall cybersickness was lower than those that involved virtual turning, which may affect the generalizability of our results. Second, it will be interesting to compare our technique with previous slope simulation techniques. Finally, the proposed deformation method did not preserve the right angle in the slope region. The objects in the middle of the slope are distorted. A more complex implementation is required to address this issue. In conclusion, space deformation created a realistic feeling of being on a slope. This technique and the multi-sensory approach we used in the work can provide novel VR experiences and useful insights for future design iterations. This technique and the multi-sensory approach we used in the work can provide novel VR experiences and useful insights for future design iterations. That's all. Thank you for your listening.